This is Automotive Electronics Test 9, and we're going to plow through these questions here pretty quick. There's quite a few of them, but we're going to try to expedite this morning. Technician A says trouble codes will direct the technician to the circuit with a fault.
Yeah.
Technician B says trouble codes will locate the exact failure in the circuit.
Yeah.
Okay, number one, that is A. You will actually, it'll send you in the direction that you need to go. It's not going to tell you exactly what's wrong in a lot of cases. Some cases you'll get a pretty close idea, but in other cases you won't. But you need to know you need to know more than pull the trouble code, get the code, replace the part. I mean, you got to know how to check the part too. Chelsea, turn those computers on over here. Which of the following is an example of a piezoelectric sensor? Oil pressure.
Knock sensor?
Knock sensor, that's right. It squeezes the quartz, it makes voltage. Technician A says a computer will make control commands to various output devices during the output function. All right? Technician, output function meaning whenever you're plugging in your scan tool and you've got your two-way communication and you're telling it, I want you to do this, I want you to do that, because you're wanting to check it. Come on, Ed. This is Ed, he's the pots man. Come on in here, Ed. And how do you put this? Stick it on my desk here if you don't mind. Thank you, sir. All right, now then, Technician B says a computer uses the input information and compares it to the programmed instructions during the processing function. Okay, that's number 3. That's C, actually.
Well, I'll be glad when my get back.
Are you having a hard time?
No, I just get it long in that shop.
Oh, bless your heart. You know, plenty of work to do, though.
Yeah.
I know you're making Sam really happy. All right. Technician A says positive temperature coefficient thermistors increase their resistance as the temperature increases. Do you remember the difference between positive and negative temperature coefficient resistors or thermistors? If it's positive temperature coefficient, it goes the way you would expect it to go. If it's negative temperature coefficient, it goes the opposite. If, in other words, you'd expect it to have more resistance with more heat, right? All right, but on the negative temperature coefficient, as the heat goes up, the resistance goes down. Negative temperature coefficient is how all of our sensors on our cars work today. If you go out there and there's any kind of a temperature sensor, that's how it's going to work. The hotter it gets, the lower the resistance is going to be. What does that mean? You're feeding 5 volts in there, the 5 volts is going to go away. 2 wires going to that sensor, ground and the signal, right? It's a 2-wire sensor. All right, as the resistance decreases, the voltage is going to get lower. You're still going to have some voltage, but basically, as it decreases, you're dropping more and more of it. Right? Across that. Dropping less and less. I'm sorry. So basically, you're going to start out with, like, if it's a cold, it's going to have like 3 volts, and as the car heats up and the resistance goes down, it'll go down to like 0.6, 0.5, that kind of stuff. I used to measure the resistance on the fan. On the coolant sensor on these Fords to see what the fan would come on, and I found out I got on a good car and I got my voltmeter and I put it on there, and I'm just, because it was easy to get to the engine coolant sensor, and I'd plug that voltmeter in, I set it right there and hook it between ground and that sensor, and I would just watch that voltage, and when it got down to, on that Taurus of that year model that I was fooling with, when it got down to 0.45, that fan would kick on, and it would stay on until it went up to about 0.50, and then it would go off. There's always a differential there. Okay, so what did I do that for? The reason I did that was because if I get a car that the fan is not working on, and, of course, there's a bunch of different ways that I've told you guys about catching fans, that were bad. I'd plug that thing in and look at that voltage, and when that voltage would go down, 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 if it hit 45 and it kept going down, the fan didn't kick on. I knew there was something rotten in Denmark. Got it?
Yeah.
So just remember that. If you check good cars, and you know what the good cars... Jeremy, can you put some rear shocks on an 98 Camry for me today? You glad to do that? Huh?
I can attempt it.
You can attempt it.
That's right.
Well, you know good and all well you can do that. Because you're the man.
But I'm 4C then, right?
Yeah, 4 is basically a C. Yeah. No, I'm sorry, 4 is A. What does the other one say? Technician B says the temperature decreases, negative coefficient temperatures reduce their resistance.
Okay, I didn't read that one.
Now, if you'd have put increases instead of decreases, that would have been right. Which of the following would not be considered a computer input? Throttle position sensor, part neutral switch, magnetic pulse generator, or EGR vent solenoid?
Part neutral switch.
Come on. Does the computer need to know whether it's in park or neutral? It does, doesn't it? So that is an input. What do you know about the EGR vent solenoid? It's something the computer controls. If the computer's controlling it, it's an output. If the computer's getting information from it, it's an input. All right, you got that? Okay, now then, let's see. The technician A says a NOT gate simply reverses binaries 1s to 0s and vice versa. Technician B says an AND gate operation is similar to two switches in series to a load. All right, now this is the kind of stuff you're going to pick up when you're reading the book because they'll have pictures of that. And they'll show you what an AND gate and a NOT gate is. They got these little the gate. This is a little part of a circuit, right? And so basically, what you're wanting to know, like for instance, if you were thinking about, say, I'm going to put a high mount stoplight in a car that doesn't have one. Got it? I want that high mount stoplight to burn whenever you mash the brake. Now, on the ones that have orange tail lights, orange turn signals and red stoplights, then that's going to be a little tough to do. Well, that'll be easy to do on those, but it'll be tough to do on one that has the red tail lights, the red stoplights that blink, because I don't want my silly high mount stoplight following my turn signals. I want it to stay on all the time. So basically, if you're going to put a little electronic circuit in there, you need to have it so that anytime there's any current coming in through either wire, this light's going to be on. See that? That's an OR. So an OR basically would mean either this wire or that wire can cause that circuit to turn that light on all the time. An AND is going to be it's got to see both of them. You see what I'm saying? This is the kind of gates we're talking about. I'm just giving you a quickie on that. I don't get too deep into that right now. There's lots of, they learn about that in electronics over there, and this is really not anything you need to know to fix a car. Basically this is the school aspect of it. Some things you learn the principles and you kind of burn them in and you move on past them because the temperature stuff that you talk about in an air conditioner, which would be the latent heat of vaporization and all that kind of stuff. That's really principles you need to know, but you're never going to use that fixing a car. But it gives you an understanding of how this stuff works, right? So that's what. And basically, Ohm's law is something that you probably won't ever use fixing a car. You probably won't ever use. You need to understand it, but you probably won't ever use it. See, after a while. But there was somebody that wrote an article in the Action magazine about that one time, about the best mechanics that they ever knew, the top guns, the troubleshooters that did everything, that didn't do anything related to Ohm's law or latent heat of vaporization or any of that when they were fixing air conditioners. They just knew how to make it work. Okay, I'm not trying to tear down the people that teach that stuff because I teach it too, but still, I try to maximize the stuff that you're going to be needing to fix a car. That's the point, right? Okay, let's see. That number 6, by the way, is a C. Park neutral switch is being tested. When the transmission is placed in the park position, the voltage at the switch is 12 volts. Transmission is shifted in reverse, the voltage dropped to 0. Technician A says the park neutral switch needs to be replaced. Technician B says the park neutral switch is operating correctly. Now we have to visualize what we're talking about here. A park neutral switch is being tested when the transmission is placed in park. The voltage at the switch is 12 volts. Now what kind of switch are they talking about here? That's what I want to know. What kind of car? How's it wired up? Because my gosh, there's park neutral switches that just supply ground to the ground side of the relay and all that kind of thing. I really don't like that question, so I'm just going to throw you the answer to it. They say it's B, right? You got that? This is just. That if I read that question on an ASC test,
normal switch, click.
Yeah, if I was reading that question on an ASC test, I would want to know what kind of idiot wrote it. With all due respect, because that question is not easily figured out. Even for if a mechanic reads that, they go, "Wait a minute, what are you talking about? Where are you testing this at? And how's it wired? Show me a schematic, and I'll figure this out." But if you ain't got a schematic, you're of all people most to be pitied here. What is the whetstone bridge used to measure? Is it used to measure how sharp your knife is? That was a joke. Let's see. That's number 8. That is used to measure pressure, temperature, and mechanical strain. All of the above. It's everything.
What is that?
Whetstone bridge. I'm going to have you to research that because that's another one of those things you won't ever use. Whetstone bridge. Look up Whetstone bridge. Do it on your smartphone right now. You want to tell the rest of us what a whetstone bridge is so that I won't be say something stupid and give bad information. Technician A says, and the output of a Hall effect sensor can be checked with an AC voltmeter. Now you need to read those questions instead of just writing the answers down there, Zach. Okay. Technician A says the output of a Hall effect sensor can be checked with an AC voltmeter. Technician B says the output of a magnetic pulse generator can be tested with a lab scope. Incidentally, did you guys know that today is midterm?
Really?
We're half done. You know how fast this semester's going? I mean, it's blowing by at warp speed. Anyway, the output of a Hall effect sensor can be checked with an AC voltmeter. Can it? Technician B says the output of a magnetic pulse generator can be checked with a lab scope. That's B, right there. I will tell you this, though.
Okay. Know what it is.
What is it?
It's an electrical circuit used to measure unknown electrical resistance by balancing two legs of a bridge circuit. One leg of which includes the unknown component. Its operation is similar to the original potentiometer. And it tells you who is.
Aha, there you go. Whetstone Bridge does about the same thing potentiometer does. They just do it a different way, right? Technician A says the output of a Hall effect sensor can be checked with an AC voltmeter. They say this. They say that answer is wrong. I believe that you can check it with an AC voltmeter. No, I'm sorry. Never mind. Not an AC voltmeter, because that's only checking above and below zero. AC was what my mind blanked out. You ever go to pull out into the road and look both ways? You don't see a car, and you start to pull out, and a car goes by. You ever do that? That's what happens to me right
I hit
here.
my coach like that.
Yeah, exactly. I mean, you don't even, you look back and forth and you don't see a car coming, you start pulling, a car goes by. Everybody's got a blind spot in their eye. And if that blind spot in your eye, where the optic nerve comes in, if that blind spot happens to eclipse that vehicle, you won't see it.
Or there's a big truck in the way.
A good that too. A good school bus driver, if he's pulling out there, he will look back and forth about 5 or 6 times before he ever pulls out, even if there's nothing coming.
Red light this morning. I looked both ways, didn't see nothing. Then I looked again. There was a cop. I was about to run that red light.
You ever notice how stressed out you get when you look in your rearview mirror and there's a cop riding back there? You're looking down at your speedometer. You're wondering if my license plate's expired. What the hell out there? And then what makes you feel really cold is when he goes, woo! If he turns his light on. I hadn't been stopped in a very long time.
And he drives around you.
Yeah. Technician A says the output of one computer can also be used as an input to another.
Yes.
It can. Technician B says a sensor is an output device. Okay, number 10 is A only. Number 11, Technician A says RAM, random access memory, will store temporary information that can be read from or written to by the MP, microprocessor. Technician B says ROM can be written to and changed by the computer. ROM, that's A only, because ROM is read-only memory, RAM is random access memory. So RAM is, remember what I told you, RAM is like your workbench. Basically, when you reboot your computer, you're clearing everything off the table, and whenever you boot your computer back up, your hard drive is saying, okay, here's my operating system, here's the programs I'm going to use, and it's laying them out on the table. The RAM is your workbench, got it? But when you shut it off, it's volatile, it goes away. And RAM, the reason we load our operating system in RAM is because it's so fast. You can read in and out of it so fast. If you were having to use your operating system off your hard drive, everybody would be angry because their computer's too slow. All right. Yep. Technician A says electrostatic discharge will destroy a PROM chip. Programmable read-only memory chip. Yep. Did I miss 12? Excuse me. Technician A says a non-volatile RAM will lose its memory if removed from its power source. Non-volatile means it will not lose its memory. That is like your speedometer, your odometer stuff. Technician B says volatile RAM is not erased when it's neither one of those yo-yos is right. They're a bunch of space cadets. Okay, number 13. Technician A says electrostatic discharge will destroy a PROM chip. Technician B says installing a PROM chip backwards will immediately destroy the chip. Let's see. Technician A says high side drivers control the ground side. Now, the PROM chip, let me ask you this. The PROM chip is something, and this is an old question, but the PROM chip is basically what we would, on the older GM engine controllers, a lot of them had the same part number, but the PROM chip was different in each one. And it was a little centipede thing. You've seen these little black centipede looking things? And you take this cover off the engine controller, and you had to put it in there just the right way. Now, the later ones had a little carrier that was easier to handle and made the chip less likely to mess up. So anyway, you have to plug that in the right way. And there's a little dimple on one end of it that lines up with a little mark, so you're supposed to plug it in. We'd have to change those. And occasionally, we would have one that would run bad, and the only thing that would be wrong with it would be that prom chip, called a rough addle, stuff like that. And I had a little Radio Shack digital multimeter that had a little chip in it that had like 8 legs on it, and that meter would go crazy and start putting decimals in places where they didn't belong and all that kind of stuff. And so I went to Radio Shack and I found a little chip like that, and I took it back and I took the little desoldered the little chip from the board, and I put a little socket that would take a chip that size and soldered it into the board, and I took this little chip and just plugged it in and fixed my meter. I don't ever do that anymore. I was all crazy about stuff like that. All right, but hey, I felt like I had done something. Technician A says high side drivers control the ground side of the circuit. What is the high side driver? High side driver is one for the hot side. You got the ground side, you got the hot side. High side driver is hot side. You're gonna need to know this. This is something you need to know because you're gonna see codes that tell about high side drivers, low side drivers. So the high side is going to be the side that shoots it to the hot. If it's turning the hot on, off and on, that's a high side
So
driver.
basically, the injectors is the low side.
Yeah, on just about every car. Just about every car. Technician, and remember what I told you: transmission solenoids in Japanese transmissions got high side drivers. They turn the hot off and on. And old Jeep Cherokees do that too. Old Jeep Cherokees, 8790. Let's see. Technician B says high side drivers may be capable of determining circuit faults. Number 14, that is B. 15. All right. Which of the following would represent the number 255 in binary code? Come on, guys. Y'all did that worksheet I gave you on that. Don't start with me. 255 means what? Every switch is on, right? So that's going to be
Oh yeah, B.
1111111. Which of the following is responsible for sequential sampling? DMUX, driver, MUX, or register? Now see this? See how important it is to read those chapters? That's going to be C. That's MUX. Technician A says a microprocessor commands out actuators by output drivers. Technician B says outputs are never controlled by supplying voltage to the actuator. Oh, nonsense. Number 17. That is a B. Now this is silly because this guy's wrong. Anytime, and I'm going to tell you what I don't like about this question at all. And anytime you see a word that says never or always, then typically that statement is going to be false. Because listen to this: microprocessor commands actuators by output drivers. Technician B says outputs are never controlled by supplying voltage. Now his answer key says that Technician B is right. Technician B is dead wrong because these little suckers right here, these little air spring solenoids on these Lincolns and stuff, they are positive side control. They're hardwired to ground and positive. You remember what we did, Sean? How we had to shoot power to these two, and then we had to ground the relay to fire up the pump to raise that Lincoln up. Of course, I couldn't tell the Lincoln was going up. I was standing on my head under the glove box, and Sean said, "Well, it looks like it's going up time around here." And I said, "Oh, I can't feel it going up." And whenever we got through, I got out and looked, and it looked like a high rider, man. That thing was all back down. Oh no! So I had to energize the other solenoid and lower it back down so she could drive it for a few days. Her car's fixed, by the way. She had to have that little computer. We put it on there. But I mean, that question is a bad question. I need to send him an email. The only problem is if you send an email to these people too often, telling them where their mistakes are, they send you a bunch of stuff they want you to proofread. You know what I'm saying? That's happened to me before.
Why?
Because they want somebody to proofread it that will catch the mistakes. And if they send that, they do. They'll give you some money, but I can't do it on college time. See, I had to go home and do it at home, and then my wife takes all the money. So anyway,
Either way, you lose.
yeah. Anyway, if you want to get this one right according to the answer key, you're going to put B, but that ain't right because it can be controlled by by power or ground. All right, I'm hurrying. Technician A says open circuit testing of the BCM power supply will indicate if there is a high resistance in the circuit. Technician B says open circuit testing has the potential to mislead proper diagnostics. Now, what is open circuit testing? That means you're testing it whenever there's not any current flowing, right? Right. So that number 8, that's C basically. It can mislead. I had that. I told you about that one time I was using a test lat and trying to. I wasn't using a test lat. I was using a meter because the book says if it's got more than 11 volts at this terminal, then go on down the chart. And so I did
That's
that.
bullcrap. Don't even follow them.
And that stuff is nonsense. And what happened was that relay, there was 11 volts there, but there wasn't enough current. But you can have voltage without current, right?
Mm-hmm.
I mean, I can hold on to one side of a meter. Touch a battery and hold on to the positive side of a meter, but the ground took the other side, and I read voltage coming through me. I don't mean it'll do nothing.
Right.
You just see voltage, right? But you take your test light and use a good. I'm not talking about one of them high impedance test lights. You're going to take a test light that the people at other colleges and other instructors will say you'll burn stuff up with. That's the one you want to use, right? And you hook that up and see if it fires up a test light, it's going to burn. It's going to pull your circuit, whatever it is. 18. Technician, Technician A says a pulse width modulated actuator cannot be tested with a digital multimeter. Well, it depends on the digital multimeter. I got one that'll test that. Technician B says the pulse width modulated actuator may be tested with a lab scope. Second one's right. B, a high side controlled actuator fails to operate. The scan tool displays 0 amps on the control circuit when the system is turned on. Technician B says this may indicate a short to ground in the circuit. Number 20, that is C.
Where's Technician A at?
Yeah, he never got into the act, I don't guess. Isn't that funny? Technician B says, see, that question is poor too. So that's ridiculous. Number C. All right.
Number C.
Yeah, just put C down there. Okay. Okay, here we go. A relay coil circuit is controlled by a low side driver. That means it's grounding that relay coil, right? Direct battery feed is connected to the other terminal of the coil. So you got power going on one side of the relay coil, and you got the driver from the engine control, from the BCM or whatever. If the BCM monitors voltage on the control circuit to determine proper operation, which of the following statements is not true? All right, let me get you this. What are you going to see? What you're going to see here, you got B plus coming in here, and you got your coil on your relay, and then your engine controller or whatever, BCM, not BCM, is supposed to actually ground that. All right, but the BCM, while it is supposed to ground it, it's also monitoring this circuit right here. What is the BCM going to see right here when this is powered up? What's it going to see right here? It's all the BCM is actually measuring it here, and the BCM can control it here. When the BCM controls it, this should change. What are you going to see here? 12 volts. And whenever it closes it, what are you going to see then? 0 volts. That's right. So it neutralize that. You're reading the 12 volts coming through all this winding and everything. Got it? Yep. Most relays, incidentally, have got a little clamping resistor in there like that so that it won't spike whenever it turns off. All right, you got that?
Yep.
Now then, so which of the following is true? 21? That's going to be C. A constant low voltage may be the result of opening the circuit between the battery and the coil. If it always reads 0 volts here, then you've either got a blown fuse up here or a burned out coil or a broke wire. So you ought to be seeing 12 volts coming through there. The other day, me and Sean did that on that air conditioner on Cherry Zoos. I was talking about this in the office a while ago. Pull the relay out, and if you got the air conditioner turned on, the AC clutch relay, and the clutch is supposed to be running, the AC clutch relay is going to show 2 powers and 2 grounds. Got it? One ground is for the coil. One ground is coming through if you unplug the relay. One ground is coming through the compressor clutch. We did not see one coming through the compressor clutch, and that's what led us to the compressor clutch. All right. The other two, the power coming in that's supposed to feed the compressor clutch is one of them, and the power that's actually feeding the coil is the other. So as if you remember that a relay, whenever that circuit is energized and it's supposed to be, if you know the circuit that the relay should be turned on, you need to see 2 powers and 2 grounds in that relay socket. Got it? But you better know which one's the load before you start jumping power in there. If you jump power, let me hit you with it. If it is grounding, let's say you measure 2 grounds, but because of the way the relay is configured, you don't know which one is going to your load. You say, well, I'm going to go ahead and just jump power into both of these grounded ones and see what happens. If you jump it into the one that's coming from the engine controller or the BCM, you fried the BCM. You better make darn sure you know which one it is. So how you do that is you take your test light, hook it to hot, you ease it into this terminal that you suspect is feeding the compressor or whatever. You unplug the compressor and see if that light goes out. If you unplug the compressor and the light goes out, you know that you've done the right one. If you hook it up and you unplug the compressor and the light stays on, you say, I better not put a ground on that one or I'm going to cook something. See what I mean? If you just indiscriminately start jerking stuff around in there and popping, power in places and nothing like that, if you got to make darn sure you know, these right here, the relays, the terminals are all the same color, and if you don't know those really well, you better not go there. On the other ones that have two big terminals and two little terminals, the little terminals will be the coil, the big terminals will be the load carrying terminals. See? All right, let me move on. Did you guys soak that up, or are you just sitting here with deer in the headlights?
Deer in the headlights.
Deer in the headlights? Your deer in the headlights was looking at your cell phone. That's what your problem was. Okay. Let's see. An actuator that receives direct battery feed and is controlled by a low side driver has a short to ground in the control circuit. That means that it's controlled by ground and is shorted to ground. Technician A says this may cause battery to drain overnight. Technician B says BCM will no longer have control. Both of those guys are right. 23. The flashing of a computer is done to perform which task? Repair hardware problems within the computer control system. Update the software. That's what it is, right? Update the software. Number 23. We're going to update the software. We can do that here because we got a flasher. What method MAT be used? They misspell that. May be used to check a computer control actuator. Number 4. To miss D. All of the above. You can use a lab scope. You can use an ammeter. Monitor current flow. You can use a scan tool to activate the component. There you go. Now, number 25. Last one on this particular test here. When measuring the voltage on the power feed circuit in the computer, the voltage reads 12 volts with the connector unplugged. When load tested with the test light, the voltmeter reads 12 volts. When the connector is plugged back in and probed, the voltmeter reads 9 volts. Technician A says this may be due to an internal problem with the computer. Technician B says this may be due to an open computer ground circuit. Who's right about that? Okay, now then, let's look at this. Let's see when you read those questions like that, you really have to wrap your head around them. You're not the one that Sam Miller talking about. Here's your computer. Right? B plus is supposed to be feeding it right here. That's what we're talking about, right? Power feed circuit to the computer. That's a power feed circuit to the computer. Of course, the computer's also got ground feeding it too, right? Its voltage reads 12 volts with the connector unplugged. Okay, you unplug the connector. I'm going to unplug the connector. I've got the connector unplugged. I get my meter here, and I'm reading 12 volts, right?
Right.
Got that? When load tested with a test light, the voltmeter reads 12 volts. In other words, if I take this right here and I hook my test light up to it, I'm still measuring the voltage, and then I take a test light and hook to ground, and I'm going to let this 12 volts burn my test light while it's unplugged from that. Got it? You understand what I'm doing here now? I'm going to let it burn the test light while I'm checking the voltage. That's what we're talking about doing. When load tested with a test light, the voltmeter reads 12 volts. When the connector is plugged back in and back probed, which means that we plug the connector back in to the computer, and then we're going to go in to the back side of the connector and we're going to measure it there. The voltmeter reads 9.5. Technician A says this may be due to an internal problem in the computer. It's not going to be an open computer ground circuit. It will not read less if it's got an open ground. It will, if it's got something in here that's trying to short that 12 volts out, you got issues. So number 25 is going to be D. You guys got that? You understand what we were doing there? Now typically, if you got good strong 12 volts there and something's pulling it down to 9.5, you got an issue there. All right, I'm going to stop that one.